Oh, by the way, where's Prince Wu? Let's welcome him. 啊，从印尼来的，你听得懂中文？好，那我们就中文上课好了。帮你上。You can try the first one. That difficult? Okay. 邓世轩啊，邓仁轩。How can you do it? U is log x. Why? That's right. This part is just the u. So if you let u be log x, this of course you turn everything into u. This is u, 1 over u, du. Now I don't know whether I can integrate this, but at least I simplify the integral. Okay. The objective is you first make it simpler. You can use now this one there's no logarithm, and things of course become simpler. So I represent everything by u and du. And this one, what's the next? Right. That's a constant, and this is interesting. Okay. Now don't mess up. So it's log x. Log x might be negative. But I take the absolute value. Okay. I take the absolute value.
Well, the advantage of electrical engineering over other departments is that the students in electrical engineering, not only you are asked to learn the hardware, in the meantime you are asked to learn the software at the same time. Of course, you're going to go through a little bit time when you are in the college, in the university, undergraduate level. But according to my 30 years experience, if you survive the trip over here, the payoff is good. Okay, I think you remember the number I tell you in the first lecture of this course. The starting salary for entry-level engineers, okay, electrical engineers is much higher than other engineers, right? So it will pay off, okay. But the downside of electrical engineering is that you are going to take the high-tech lynch because you're going to take a lot of courses which might consider very hard. So this, I think, the digital circuit design might be the most soft one, okay. It's lenient, right? It's easy to take. When you are going to the second year and when you become a sophomore, you're going to take a few hardcore courses. Okay, the first one will be electronics, and then it comes as electrical circuit, and then you're going to take engineering mathematics, right? And then after that, you have to face the challenge of electromagnetic theory. Okay, when you become junior students, then the motor comes with that EM waves. You are going to learn how to analyze and design a motor. Okay, it is called electromagnetic electromachinery. So a lot of hard courses are ahead of you guys. Okay, so I don't consider it's a big problem. Okay, most of the students will survive the trip, according to my experience, but some of them might not feel it's too comfortable in the double E engineer. Well, if this is the case to you, I won't be surprised, and I also encourage you to consider there's another possibility in your career development. Okay, I've seen students drop out the double E department. I've seen that. Okay, of course. Okay, it's not automatic. It's not automatic that you will survive down the stretch. It's not. Okay, you gotta take some determination to do that. Okay, the first year you here in the first year, I think this is the one that you consider as the most difficult one, but in fact it's not. Okay, I think this is the most lenient courses in your career of double E engineering.
You might wonder why end is not pointing to the last element. This is for we can change this function code. For example, we can change end to we can change the function called end to begin, and we can use +3, and this is like pointer addition. So this pointer is pointing to 3 elements after the first element. So end is also I change this example to the one in the slide. And this vector has 5 elements, and I want to declare another vector, her vector, and I want to copy this vector, copy my vector as the initial value of her vector. And the first input is a pointer, and the first input is a pointer pointing to the first element you want to copy, and the second element is also another pointer. And suppose we want to copy 5 elements, then you use +5 here, and the size of her vector is 5. And if you only want to copy 3 elements, then you simply change +5 to +3. And now the size of her vector is 3. So my vector dot end is like So my vector data end is equal to my vector data begin plus my vector data size. You can verify this. You can verify this fact. For example, I print. This is the comparison. I compare my vector data end with my vector data begin plus my vector data size, and the result of this comparison is true. So its value is 1. So my vector data end is actually equal to my vector data begin plus my vector data size, and this plus is it's not ordinary addition. This plus is pointer addition. So it is the pointer. It is the pointer my vector data begin plus some integer returned by my vector data size.
Can you talk about bonus 17?
Bonus 17. Don't show me the problem, okay? Oh, this is good problem. Okay. Now we don't have a lot of time, so we do it one by one. First of all, the past homework. Okay, we talk about the past homework. The main thing is the main mistakes, several mistakes. Still, we have something like this, which is wrong. Okay. For example, this is page 214, number 20. We have x squared, y squared. When you differentiate, what is it? Some students get is 2x times 2y, y prime. This is exactly following this incorrect formula. All right, so this is wrong. Be careful. At least five of you had this mistake, which is serious. And in fact, the problem is like this. This is given, and there are several methods to do it. I found two, actually three methods in your work. Well, it's not me who find it; it's the TA who found it. Okay. This is the problem, implicit function, and we want to find dy dx. So method one, you differentiate, and some students, how did they get? Because they square both sides and differentiate. In fact, they are the same. They are the same. So if you differentiate the left-hand side, this is a product. Okay. So y is a function of x. Just imagine, and so you have y, and then plus x y prime. This is to differentiate the left-hand side. This y prime is dy dx. Okay, and then the right-hand side is a square root of something we call u. All right, and so it's 1 over 2 square root. So this is u to the power 1/2, and so it's 1/2 times u to the power -half. -half is this one, and then du dx. Du is 2x and then 2y, y prime. Right, and of course this 2 we can simplify, and then the next step is to, there is a y prime term on the left-hand side and on the right-hand side. We collect them. And so, but be careful, there's a denominator here. So it's x minus y over x squared plus y squared. And then the whole thing times y prime. And all the other terms, we move it to the right-hand side. Minus y, right? And so y prime will be equal to this x over now, if you get this answer, it's acceptable. It's okay, right? It's okay. But you can make it simpler because you have this so-called identity, right? You have this equation. The square root is troublesome, but square root is just x times y. And so if you change it to x times y, if you change this one to x times y, then it's a lot simpler. This y will get cancelled, and am I correct? I'm correct, right? I'm correct. And the same thing with this numerator. This square root in the numerator. And so it will be x, not x, 1 over y minus y over x minus 1 over x. And so if you take this y, and then this is 1 minus y squared. And this, you take the x, which becomes the numerator, and then x squared minus 1. Now this is a simple answer. Okay? This is a simpler answer. Of course, it's better, but this is also acceptable. Right? Now, this is method 1. You find y prime. And the method 2, some of you directly using this and find out y as a function of x, which is also acceptable. But you see, So x squared y squared is equal to x squared plus y squared. And so x squared minus 1, no. And then differentiate. So it's 2x y squared plus x squared 2y y prime is equal to 2x plus 2y y prime. And then collect the y prime term is 2y x squared minus 1. Is it like this? No, sorry. I don't want to do this. Now this is another method, but it's in fact similar, doing the implicit differentiation. Okay, this is implicit differentiation. But I have another. Well, I call this method 2. Okay, and then in fact we have a method 3. How? Because we still have this one, and some of you did something like this: x squared minus 1 y squared is equal to x squared, and so y squared is equal to x squared over x squared minus 1, and y is equal to this square root plus and minus, right? And then is equal to plus and minus x over square root x squared minus 1. Now, and if you are careful looking at, so you have 1x corresponds to 2y, it might correspond to 2y, but actually in squaring, here you square, you might introduce an extra. For the same x, you might introduce an extra y. So this plus and minus, we need to be careful. In fact, here the right-hand side is always non-negative. Essentially it's positive. And so this x and y, they must have the same sign. And so from the correspondence, in fact, this it seems it should be plus and minus, but in fact, this minus cannot happen. Is that clear? Now, in fact, this is the weak point of this method. You want to, it's not always possible. Sometimes you want to express y as a function of x directly. You want to make it an explicit function. And this time it's possible. In this time, it's possible. Y as a function, there is a positive and negative. But in fact, the negative is impossible. Right? If you look at this one, the original equation. From the original equation, y has the same sign as x, or xy have the same sign. And so you get a simpler expression for y as an explicit function, and you can differentiate, get y prime. Okay, find y prime, and of course you get the same thing like this. So we have actually 3 methods to do it. Now you need to be careful. For example, for here, when you square, here these 2 methods, when you square, you allow originally y has the same sign as x, as this suggests. But when you square, this y can have opposite signs, right? And so you introduce another solution of y, which is not we want. You need to be careful, right? This method 3 is not always possible. In this case, it works, but it does not always work. So that's the good thing about implicit differentiation. It always works. It works all the time. So it's very nice.
The only thing I can do for them is that I teach you the way how to solve the equation, but I cannot do it for you during the exam because I was not supposed to do that. It's not my job. The job of a student is that you got to learn that. You got to take some time to do the practice, all right? So like I said, it's a practice of shooting the basketball in the court. Okay, if you don't do the practice all the time, so how the hell one day you're asked to get on the in the court and to play the forward or the center, when they give you the ball, how can you put the ball into the basket? It's impossible. So I'll tell you the way, and you got to do the homework exercise, and then you'll become the expert very soon. It is my belief that you are all a quick learner, and it is a blast for you boys and girls to get into electrical engineering, because I remember in the first lecture I told you one cruel fact is that electrical engineers, particularly for the IC or IC designers, or the the engineers in this field, they are all they are paid very well, much better than the other department. It takes some time to grow up as an engineer because you have to take a lot of, I say, the hardcore courses. Okay, this is not a really hardcore. This is a soft core. It's not hard. Okay, it's an easy one because in the second year, if you're alive, okay, in the next year, alive, okay, you're going to take circuit theory, okay, microelectronics. You're running into the big wall, set by the EM waves, a lot of mathematical equations. And some of you will feel dizzy in the class. Okay, it happened to me or my friends before. The first time when we solved the Maxwell equation, I say, what the hell is this? Okay, who developed this kind of equations? Okay, some persons close to God, they developed this equation, and they try to torture us in the next 3 centuries. Okay, but in the end, people prove all these equations, they are fundamental to the human civilization. Okay, based on this equation, we have wireless communications. We have a lot of affordable electronic devices, okay, that, for example, your cell phone, tablets, this kind of thing. Right, you will be the one to take over the torch, the responsibility to develop another level of a civilization very soon. Okay, let's go back to